In this video, I'm going to show you how to multiply decimals. So I'm going to start out with 2/10 times 4/10, and I'm going to purposely change both of these decimals to fractions so that I can show you a pattern that's going to emerge when I multiply decimals. So to multiply fractions, I'm just going to multiply the numerators. 2 times 4 is 8, and the denominators, 10 times 10 is 100. I can change this back to a decimal. 8/100 is 8 in the hundredths place. Let's now look at 5/10 times 9/100, and I'm going to do exactly the same thing. I'm going to write them as fractions, and then I'll multiply the numerators, and the denominators. 10 times 100 is 1,000. I can rewrite that as a decimal. 45 ends in the thousandths place. Let's look at one more example. 6/100 times 8/1000. Again, writing as a fraction, multiplying my numerators and denominators. 100 times 1,000 is 100,000. So I have 48 ending in the tenths, hundredths, thousandths, 10,000ths, 100,000ths place. So now let me show you what's going on when I actually multiplied these decimals, and let me move my work over to the side here just a little bit. And I've also pulled in my place value chart here, and I had to add one more space, 100,000ths, to the end of it. So the first thing that I want you to notice is that if I were to pull out all of the zeros and the decimals from every one of my problems and just think of these as 2 times 4, I get 8, which is seen in my answer. If I think of this as 5 times 9, which is 45, again it's in my answer. And 6 times 8 is 48, which is again in my answer. So let's take a look at our first problem that was 2/10 times 4/10. And I just said that I can think of this as 2 times 4 equals 8, but then I have to do something to that 8 because clearly the problem is not 2 times 4. It is 2/10 times 4/10. But I'm going to go ahead and write down my answer of 8 in the units place as 8 ones. And then I'm going to look at my fraction multiplication problem up here and look at what I did with these denominators, because this is where I'm deciding what to do with my decimal. This is what separates this problem, 2/10 times 4/10, from 2 times 4. Because if it was just 2 times 4, we wouldn't have any of these denominators right here. So my denominator is 100, and this is where basic knowledge of fractions will tell you that 8 over 100 really means 8 divided by 100, because fractions are just division problems. Now, if you haven't learned about dividing by powers of 10 yet, this would be a good time to pause and watch my other video about dividing by powers of 10, because what I'm going to do next is I'm going to take my 8 that I've placed in the units place, and I'm now going to divide it by 100. And when I'm dividing by 100, 100 is really the same thing as 10 times 10, or 10 squared. So when I'm dividing by powers of 10, I can take my digit, the 8 that's in the ones place right now, and I can move that 8 2 places to the right. Now this is not a place value right here, this is just my decimal. So 1 place, 2 places to the right. And now that I've moved my digit 2 places to the right, I can fill in every other place it's between the decimal and it with a 0. And you can, and convention just says to put a 0 in the ones place when we have a decimal there. And so we've now see how we got our answer 0 and 8/100. So let's look at the same thing with our next problem. Let me erase what I just wrote on here. And in the next problem, I treated it as 5 times 9 equals 45. So I'm going to write that answer, 45, in my place value chart. But on this problem, what separates this from just 5 times 9 is that we have 10 times 100 in the denominators, because this really is 5/10 times 9/100ths. So I need to take that 45 and I need to divide it by 1,000. So when I take 45 over 1,000, that equals 45 divided by 1,000. And 1,000 is really 10 times 10 times 10, or 10 to the third power. So we are going to take our 45 and we're going to move it 3 place values to the right. So here is 1 place value, 2 place values, 3 place values to the right. I can now fill in any place values between my digits and the decimal with zeros, and I can put my 0 in the ones place because I have no whole numbers. So my answer is 0 and 45 thousandths. Let's now take a look at what I did on the last problem, the last example that I have up here. So let me erase what I just wrote. And on my last example, I had 6 hundredths times 8 thousandths, but I'm going to treat it like 6 times 8 is 48. And then I'm going to deal with the hundredths and the thousandths by dividing that. So I'm going to go ahead and write 48. And then after that, I know I'm going to have to do something with hundredths and something with thousandths. So I have 48 over 100,000, which equals 48 divided by 100,000. And 100,000 is really 10 times 10 times 10 times 10 times 10. There are 5 tens there, and you can kind of see that because there are 5 tens right here. So there are 5 tens in our answer as well. So this is really 10 to the 5th. So we know that we need to move our 48 5 places to the right. So I'm going to take my 48 and move it 1, 2, 3, 4, 5 places to the right. Now I can fill in any zeros, put my decimal on there and a 0 in the whole number place value, and I can see that my answer is 48 hundred thousandths. Now if we go back and look at each of these examples, we'll discover that there is actually a shortcut that we can use here. In each of my problems here, if I just look at how many digits or how many place values there are after the decimal, that will tell me how many place values I'm going to need to move my answer over if I ignore the decimal. Because I had 110 and 110, that tells me I needed to move it over 1 2 tens. Because I had 110 and 2 tens here, that tells me I needed to move it over 1 2 3 tens. And because I have 1 2 tens and 1 2 3 tens, 2 tens here and 3 tens here, I needed to move it over 5 tens, 1 2 3 4 5 tens here. So let's look at another example, this time with a little bit larger decimals. Let's do 6 2/10 times 4 5/10. And if I were to write this out as a fraction problem just like I did before, 6 2/10 would actually be 62/10. The reason for that is each one of these holes right here, each of these 6 holes is 10/10, and I have 6 holes, so that's 60/10, plus these 2 more tenths right there gives me 62/10. This one right here, 4 5/10, this would be 40/10, plus these 5 more. 40 plus 5 gives me 45/10. So if I apply what I just learned in our previous examples, I can ignore the denominators for right now and go ahead and multiply the numerators. 62 times 45. And you're welcome to use whatever method of multiplication works best for you, as long as you have some method, whether it's lattice or traditional or partial products. some method of multiplying whole numbers that will give you a correct answer. So I got 2,790 for my numerator, and my denominator is going to be 10 times 10, which is 100. So what we just learned was that we can take our 2,790 and then divide it by 100 or move it over two place values. So I'm going to write this in 2,790, and I'm using a place value chart on this example that does not have the decimal as its individual box, because we're going to actually be using some whole numbers here, and that would it would make our place values be off if we considered our decimal to be an individual place value, which it's not. It's just a divider between the whole numbers and the decimals. So now I need to divide that by 100, which means I need to move it two place values to the right. So I'll do 1, 2. So my final answer would be 27 and 90 hundredths, which is the same thing as 27 and 9/10. So if I go back and look at my original problem, I have one digit right here behind the decimal, and I have one digit right here behind the decimal, and it's these digits that are after the decimal that correspond with my denominators in the fractions. So this one digit represents tenths, and the same thing right here represents tenths. And then when I multiply tenths times tenths, I get hundredths. And that means I'm going to have to shift my entire number, my 2,790, two places to the right, because when I divide by a power of 10, I move my digits to the right. So let me again show you the effect that moving my decimal or moving my digits had on the decimal and my answer. So I started out with 2,790. That's if I ignored the decimal and treated the problem like 62 times 45. But I divided 2,790 by 100 because I had tenths in both of my factors of my problem. So when I did that, I moved my digits two place values to the right, 1, 2. Now notice when I do that, I'll show you it again. When I do that, it has the same effect as moving the decimal place two digits to the left. Because look, the decimal is just to the right of the 0, and when I move this over 1, 2 times, it makes the decimal appear that it moved to the left twice. Now, the decimals don't ever move. They're just a divider between whole numbers and fractions. But if you want to think of it as moving the decimal over two places to the left, you can. But what you're really doing is you're moving your digits to the right in your place value chart when you are dividing by powers of 10. All right, here's another example. Let's say I have 3 and 4 hundredths times 2 and 9/10. If I were to write these as fractions, this would be 304 hundredths, because each whole is worth 100 100ths. So I have 300 of them here. I have nothing right here. And I have 4 100ths right here. So altogether I have 304 100ths. And this next factor is equal to 29 tenths. 2 and 9/10 is 29 tenths. Each of these two wholes were worth 10 tenths, so I have 20 tenths. And this is worth 9 tenths, so altogether I have 29 tenths. So when I multiply this out, I can go ahead and multiply my numerators and treat the problem as if it were just a whole number multiplication problem. 9 times 4 is 36. And we have 27. You can again use whatever method you choose to do for your multiplication. I'm doing traditional just because that's fastest for me. So I get 8,816 for my numerator. And the denominator will be 100 times 10, which is 1,000. I'm going to write my 8,816 in the place value chart. And because I'm dividing by 1,000, I need to move it 3 places to the right. 1, 2, 3. So my answer becomes 8 and 816 thousandths. if we go back to the original problem, there are 2 digits right here after the decimal that corresponds with the 100 in the denominator, and there is 1 digit after the decimal that corresponds with the 10 in the denominator. Altogether, I have 1, 2, 3 digits after the decimals, 1, 2, 3 in my denominator. So that tells me I'm going to move my answer 3 digits to the right. And if it helps you to think of your answer, 8,816, decimal will be right after it. If it helps you to think of that as moving your decimal 1, 2, 3 digits to the left, you can just understand that when we multiply or when we divide by powers of 10, we're really moving our entire digits place values to the right, which has the same effect as appearing that your decimal is moving to the left. So let's look at another example in a more traditional format. Let's say I have 43 times, let's do 9 and 94 hundredths. And I wouldn't normally rewrite this problem as fractions. That's just not a very efficient way of doing these problems, but that was just to show you how I knew where the decimal would go in my answer. So instead, I'm going to treat this as if it were just a whole number problem without a decimal, just like I did on my previous ones, because I know that's what's going to be in my numerator. So if I'm doing traditional multiplication, I'm going to always put the number with the most digits on the top, and then I'm going to line this up just like it was a whole number problem. Now, if you're doing lattice multiplication, it doesn't really matter which one you choose to put on which side, but traditional it does. Let's see, that's 36 plus 3 more is 39. Don't want to make any mistakes here. So I have 42,742. So I know those digits are going to be in my answer. I just don't know yet where the decimal is going to be. But if I go back and look at my problem, I have a decimal right here and nothing after it, and I have 1, 2 digits after the decimal in my second factor. So in my second factor, I'm not really multiplying by 994 like I did in my problem right here. I'm really multiplying by 9 and 94 hundredths. So it's that 94 hundredths, it's that hundredths part that is going to determine where my decimal is going to be. So remember, each of these place values was really 1/10. So I had 1/10 times 1/10 equals 1/100th. So 100 will be the denominator in my fraction. So my fraction really would have looked like 42,742 over 100, which means I need to shift my entire answer 2 places to the right, which has the same effect as moving my decimal, which is at the end right here in a whole number, 2 places to the left. So my answer becomes 427 and 42 hundredths. Here's another example. Let's say I have 25 and 4/10 times 52 and 8 hundredths. I'm going to ignore the decimals. I'm going to think of this as 254 times 5,208. Again, if I'm doing traditional multiplication, I need to put the number with the most digits on top, and I'm going to treat it like a whole number multiplication problem as I do all of my multiplication. So let's see, 4 times 2 is 8, 4 times 5 is 20. So we're done with the 4. 8 times 5 is 40. 5 times nothing is nothing with 4 carried. 5 times 2 is 10, and a 26. And now we're done with the 5, so I'm almost done right here. Let's see, that'll be a 1, then a 4, and then a 10. This is a long problem here. So let's see, I've got 12 here. All right, hopefully I did that correct. In my answer, I have 1,322,832. Of course, I know that's not going to be my actual answer, because if I were to estimate this problem, I could say this is close to 30, and this is close to 50, and 3 times 5 is 15 with 2 tens, so my real answer should be about 1500. So if I go back and look at my problem, I had one digit there, one here, and one here. So that means my denominator is really going to be 10 times 10 times 10, which is 1,000. So that means I need to shift my number 3 places to the right or move my decimal back 3 places to the left. So my decimal started out right here, 1, 2, 3 places to the left. So my answer becomes 1,322 and 832 thousandths. If I compare that to my estimate up here, it looks like it's pretty close.